AI is a powerful tool.
This summit can help ensure that artificial intelligence charts a course that benefits humanity and bolsters our shared values.
Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you, Anna. Hello, everyone. Good morning, good afternoon, good evening from me as well. I'm Guilherme Martinez Roura from the International Telecommunication Union, and I would like to welcome you all for joining today's AI for Good webinar, Educational Robots Providing High Quality and Inclusive Education for All. This session is part of the AI for Good robotics programming track, exploring how AI-powered robots are helping to unlock our human potential and advance the United Nations Sustainable Development Goals. We have a distinguished set of panelists today, but as always, we are counting on you, the participants, to help create a very interactive session. Without further ado, I would like to introduce our moderator today. His name is Tony Belpaem, and he's a professor at Ghent University. Tony, welcome, and the floor is all yours.
Thank you very much. So thank you all for joining us. Today, we are going to talk about robots and specifically about robot tutors. So robots that can help in the classroom. And you might be familiar with robots in school. So, Lego Mindstorms, robot kits that children put together to learn more about technology, about programming, about computational thinking. But today we will be talking about a new kind of robot, a robot that helps out by taking over some tasks from a teacher. And there are many reasons why we would like to do that, of course. One is that these robots have or hold the promise of providing one-to-one tuition to give uniquely personalized tuition to children, to teach in a way that a typical teacher who is addressing a group of children can't do. These robots could, for example, teach at just the right level, give you just the right amount of tuition, give you feedback that really kind of takes you on a learning journey. And we've got a number of eminent speakers with us today. So we've got Laura Bokenfuso with us from Van Robotics, Tony Prescott from Sheffield University and Consequential Robotics. We've got Sneha Vaswani from Miko and Pierre Guilambourg from EPFL. But before we listen to our speakers, I'd like to hand the floor to Okan Dursun, the envoy on youth from the UN, and he would like to say a few opening words.
Thanks, Tony. Hello, everyone. It's a pleasure to be here in AI for Good webinar for me. I am so excited to hear these amazing speakers very soon. But before that, I would like to share a little comments from my end. That organization is very important, especially for AI for good. There is a reason by doing that, because we need to prioritize a good, better purposes by using technology, artificial intelligence, robotics, coding. These trends, these topics are very important. And the speakers will come and explain the robotics and the solutions they are providing for the younger generation. But we need to emphasize the second wing as a compassion wing for technology. I am here as a social entrepreneur and also a young leader for Sustainable Development Goals by United Nations. I am a champion for quality education. With our enterprise, Twin Science, we are also prioritizing quality education by providing these robotics, coding, AI education. But why? This is the question we need to ask, because today's jobs and today's world is changing. And as the statistics shows that 40% of our existing jobs will lose to automation. And there are 240,000 new jobs will happening, especially with the green skills. But today's children should learn about them with two aspects. First, they need to learn about the technology of the world. This is the new trend. But secondly, they need to learn about how they can use technology for a betterment of the world or destructive reason. That is why AI for good is very important, and to encourage today's education systems outcomes and tomorrow's change makers, which is our existing children, existing students. So I am super happy to be here and so excited to hear and listen more about the upcoming speakers. I am really inspired by them and looking forward to hear more with Q&A session and networking session. Thank you very much, Tony.
So thank you. And let's go to our first speaker, who is Tony Prescott. So he joins us from United Kingdom. He is a professor at Sheffield University and is the co-founder of Consequential Robots and Bo, two companies building robots and robot solutions. Tony, over to you.
Thank you very much, Tony. So let me share my presentation. So I hope you can see that. So yeah, I want to talk about robots in the classroom, and as Tony suggested, where things might be going beyond the sort of line following and simple robots that we have at the moment. And particularly, I want to talk about robots as ways of encouraging children to take interest in STEM more generally, and also to think about how robots could also be pastoral tools in the classroom. So I'm from the University of Sheffield. I'm part of Sheffield Robotic Institute, which is across both of the universities in Sheffield. It's been going for about 10 years, and it has a membership of over 200 researchers. I'm also, my background is in research in robotics, and particularly in bio-inspired animal-like robots. These two robots that you can see on screen now are inspired by the animal in the bottom left corner, which is a rat. This is a pet rat that you can see in that picture. And these are large-scale models of the rat using its whiskers to understand and interrogate the world. And one of the unique features of our robots is that we not only try to replicate some of the morphology or the body of the animal, but we also try to replicate the brain. And you can see in the bottom middle diagram a schematic of the rat brain, and the colored ovals show the bits of the brain that we've been modeling. So that's been my life in research for more than 25 years. But in the last decade, I've been looking to create applications of robots. One area that we've worked in extensively is immersive telepresence. So we're interested in how you can remotely control a robot. In this case, my colleague Michael is wearing a headset, and when he moves his head, he automatically moves the head of the iCub robot, which you can see behind him, and he sees what the robot sees. In this case, the robot actually is looking at him. So you have this strange experience of seeing yourself from another point of view, an out-of-body experience. And telepresence is becoming increasingly important in many roles and jobs, and the ability to be able to make remote visits and so on. And the capacity to do telepresence into a remote robot increases the possibilities of doing work at a distance, for example, in hazardous environments. So I founded 2 robotics companies. The first one I want to describe to you is Consequential Robotics. And Consequential is interested in designing new kinds of robots, particularly for healthcare and, in this case, education. We've developed a number of robots. The one that's most advanced is this one shown here, which is the Miro Robot. It's designed to resemble an animal, but not to be exactly like any one animal. So it looks a little bit like a cross between a puppy and a rabbit. It has wheels rather than legs because it moves around mostly on flat surfaces. And it has inside it a powerful computer processor, and it has cameras for eyes and microphone for ears and a distance sensor in its nose. So it can do quite a lot of sensing and understanding of the world. So compared to some of the existing educational robots, this means that Miro can run more AI systems than many of the currently available education robots. And Miro also moves around and behaves in an animal-like and engaging way, and I'll show you more of that in a little while. The second company that I founded is called Bettering Our Worlds, or BO for short. And BO provides software tools, and the idea is to make robotics easier. So at the moment, when you program a robot, you have to program differently for each robot that you might want to use. So you need to change your program if you want to swap from one robot to another. BO software is what we call robot agnostic. So you write the program once, and then you can run it on lots of different robots, as shown in this graphic in the middle. There are around a dozen robots that you can run that software on. We're offering a free beta, so you can access this software for free. If you look in the top right, there's a QR code which will take you to the web page where you can register to use the beta. So if you're a robot programmer, please have a look at our website and consider signing up. So one of the things that we're doing with our robot agnostic software is enabling remote telepresence. So this is a robot in the laboratory in Sheffield, and it's not operating autonomously, it's being remote controlled by a human. In this case, the human controlling the robot's actually in Canada, and the robot is in Sheffield in England. And so we're enabling remote control of a robot across 2 continents with very low latency. And you can see that allows a considerable degree of scale. The robot can manipulate these cups and stack them almost as if you were in the room. So it's been mentioned already that digitalization and computerization robotics is going to impact on jobs. A report that was published nearly 10 years ago now by Frey and Osborne said that up to 47% of jobs in the US alone would be affected by computers and AI in the next couple of decades. A report in the UK in 2015 suggested that maybe 35% of UK jobs were at risk. Although actually in the last decade or so, although we've lost a considerable number of jobs to computers, we've also created new higher skilled jobs. So the movement is in 2 directions, and to look at this in a positive way, the hope is that robotics and computers can take over some of the less interesting, more dull, more dangerous jobs, and leave humans to do work that's more creative, more about interpersonal interaction, and generally could be more rewarding. But in order for those jobs to be realized and for people to be able to do those jobs, we need a society that has a better understanding of the technology. One of the risks of the robots taking on human jobs and computers taking over human jobs is that we hollow out some of the jobs that people are doing that are towards the middle end of this scale. This again is from the Deloitte report. You're seeing on the bottom half of the graph, you're seeing a rating from 1 to 10 of something called job quality. And on the y-axis of the graph, you're seeing whether these jobs are going up or going down. And you can see that there's an increase in some of the lower skill, perhaps lower quality jobs, and there's an increase in some of the higher skill, higher quality jobs. But in the middle, there is a hollowing out. So we're losing some good jobs, and that's a concern. We want to keep good jobs for people, and we want to make sure that people in Europe and throughout the world have interesting and fulfilling jobs to do. Addressing this challenge requires that we reskill. We need to reskill the existing workforce where their jobs are replaced or changed by robots and AI. And we also need to ensure that our children are given the right skills. In the UK, we need to catch up with the rest of the world to do this more effectively. And the good news is that robots, as well as being one of the things which is driving this disruptive change, they're also a tool that we can use in education to enable children and adults to improve their digital skills and more broadly their STEM skills, their skills in science, technology, engineering, and mathematics. One example I'd point you to is a study from the US, and robots are good at breaking down barriers and perhaps encouraging people that might not normally be interested in robots to think that there might be a career for them in the robotic space. So in this study, they had a 7-week intervention with this robot called Kibo, and they found that before the intervention, boys were more likely to say that they wanted to be an engineer than girls. But after the intervention, girls caught up with boys and said they were equally interested in becoming an engineer when they grew up. So in the UK, we've generated a report about how we can bring robots into education. You can download it here. There's a QR code link for that. And one of the proposals is that we can develop what we call learning factories, which are shared spaces where children and adults can gain access to digital equipment and robots and learn how to use those. And the idea is that we might use things like public libraries as the site for these kinds of resources. We're just starting a new project in Sheffield where we're teaming up with the libraries in Leeds and with a national company called STEM Learning, which has contacts with thousands of schools to pilot this idea of the learning factory. So just going back to Miro, this is Miro Robot in the University of Sheffield, interacting with some of the students there. Miro is designed to be friendly and to appeal across genders and to different age groups, and to be easy to program. You can see that it has some built-in AI, which is based on how we think the animal brain works. So it does behave in an animal-like or puppy-like way. We have developed in consequential robotics a system called Miro Cloud, which allows you to write your own programs for Miro in the graphical programming language Google Blockly. So you can just drag different blocks and create a program which will control the simulated Miro, which you see here on the left. And once you've got your program assembled, you can run it. The simulated robot will hopefully do some interesting behavior. And if it works in simulation, you can connect Miro Cloud to a physical robot if you have one. And you can, if you put the IP address into that box at the bottom, you can just click a button and you can swap your program so that it runs on the physical robot that you might have next to you. So this means that one AI-enabled robot like Miro could be used to teach a whole classroom of children who might be programming in simulation. And Miro Cloud allows you to use this programming environment across the internet just using the browser. You don't have to install anything on your home machine or to have a high-powered machine. So we can run this on typical classroom robots like Chromebooks. So I've almost finished here. I just wanted to finally say that another application for robots could be to take the role of classroom pets. So a survey in 2015 in the US and Canada found that classroom pets were a really useful way to encourage responsibility and leadership in students. They also provided calm and relaxation to children when they were anxious or stressed. They were particularly suitable for children with special educational needs. And they could also enhance lessons around science and nature. And there are fewer and fewer pets in the classroom for various reasons. For example, concerns about allergies and concerns about animal welfare. And we think an alternative to using pets in the classroom might be to use robots such as Miro. So we're looking to evaluate how Miro could, for example, reduce the anxiety in pupils in schools. So that's me finished. Thanks very much for listening.
Thank you very much, Tony. So if you have any questions, then you can pop them into the chat and we'll pick them up after the various presentations. So next one up is Sneer Baswani. He joins us from India and he is the CEO and co-founder of Miko, and he's going to tell us all about this.
Thank you so much, Tony. Hello, everyone. It's an absolute honor to be connecting with everyone on this platform. I represent Miko as the co-founder and CEO. We started this journey back then in 2015 as building a consumer robotics company that can focus on solving unmet societal needs. What do we do as a business? We help parents raise kids in the modern world and help them embrace embrace the society as it comes. So just to put, I'll just share my screen. Yes. So as you all are aware, childhood has seen a massive change in the past decade, where kids have been empowered with new mediums of technology and parents have started getting busy and busier in their day-to-day lives. What we started witnessing was that the emotional and social well-being of a child has started declining as well. If you see the cognitive skills, reading levels have been dropping and attention spans have been dropping. There have been lesser physical activities that kids are doing. Mental well-being has been questionable. There are rising cases of anxiety, depression in kids as young as 4 and 5 years of ages. So we started thinking during COVID as well, that the social skills of kids have actually started declining globally. So we started thinking, how can we leverage artificial intelligence for providing personalized social emotional well-being of the child? And in that pursuit, we started building a platform called Miko. What Miko does is that it's a robot that engages, educates, and entertains kids. The more children interact with it, it understands their areas of interest and initiates new experiences with them on their topics of interest. As a parent, you can buy it from a store and you can set it up on a mobile app and give your expectations to the robot on what you want the robot to focus on. And from there, the robot will then start engaging with the child, play games with the child, tell stories to the kids, spend half an hour with the child every day. And over a period of time, it starts identifying the gaps and focuses on certain areas which the parent wants the robot to focus on, and then comes out with new experiences, recommending to the child and creates new journeys and missions for the child to accomplish. After a month or two, it comes back to the parent with a report card on how the child is doing, that you told me to focus on these areas and these are the outcomes that have been seen, and so on. So with that thought process, the robot typically focuses on social skills, physical, mental well-being, and cognitive skills through a range of activities. I'll just play a very small video for you to get more perspective on what Miko is. And then I'll take a deep dive on what we've learned so far in the past few years of research and the scale that we've been able to get to as a consumer brand.
Let's go find Miko. Hello, Miko, can you hear me?
Yes. Can you hear me?
Can you tell us a joke?
Where do books hide when they are scared? Under the covers. Oh, excuse me. Good boy.
Miko, how do you stay out of sight?
How else? Camouflage.
Miko, do you want to dance?
You found me. Let's dance. I am doing the robot. Miko. Ridiculously smart. Seriously fun.
So as you can see, the robot is a very cute companion device which has been built for 4 to 8 years of age. The robot is priced at $200. You can, unlike most robots globally, we wanted something that can deliver impact at scale. So it has been priced for the market at $200 price point. We're building a range of socially interactive products across $100 to $400 price point so that it can cater to different segments of the market across the globe, and parents and families across the world can easily bring one home. Now, what the robot does, it starts understanding the child, takes recommendation from parents, drives personalized experiences, reassesses the child, and gives feedback to the parents and continues to grow with the child. The entire framework has been designed in-house. We are a team of teachers, artists, mathematicians, engineers, pediatric psychologists, and doctors who've come together to identify the needs of kids across the globe and build the tech stack. The conversational NLP has been built in-house. It starts conversations with you. The emotional intelligence stack, where it's able to understand the emotional state of the child through tonal analysis, sentiment analysis, and vision processing is built in-house. So based on that, it builds a personality profile for the child and then comes out with new experiences and new recommendations for the child to enact upon. So as a consequence, the AI, the content, and EI, just like there's an app store on your phone, we have an app store on Miko, where world over top content companies have published their apps on Miko, and those apps are initiated by the robot to create new games. Like you could play a game of hide and seek, you could play a game of freeze dance, you could play a game of charades, where the robot is a participant in the game, and the children at home and the siblings and friends can come together and play in those games, like the video you just saw. This drives engagement, and the engagement is in a specific direction as desired by the parents, which leads to outcome. Some very preliminary analysis, we've been able to identify improvement in social skills, cognitive skills, and well-being of the child across different areas. Now, these were assessed against a baseline of at the initial stage of how the children were when they were interacting, and how after 3 months, after 6 months, how the improvement in these specific areas have been. Now we've started integrating global absolute assessment tools inside the product so that parents get complete assessment reports and they can give their inputs and drive the interaction with kids. We feel children in today's day and age, this platform can be a quite essential parental aid in that can assist them in their parenting and grow with kids as a companion. So it's a trustworthy companion for the child, and for the parents, it's a reliable technology platform where they can freely give it to the child and be comforted on all aspects, from the outcomes of the engagement to the privacy to all the other aspects that surround a technology platform. Fully child safe, age appropriate, and completely designed for kids. As a brand, we have our users spread across 140 plus countries who love Miko. It's the #1 robot across the US for the past 2 years during the holiday sales. Consistently, we have an installed base of more than 250,000 robots that are being used across the globe. This year alone, we are shipping almost 1 million robots, and these robots will enter 1 million homes and create a positive and a transformative journey for more than 1 million kids and their siblings around their home. The goal of our company is how can we enter 10 million homes over the next 4-year time frame. And so in that pursuit, we are building this journey. We are a venture-backed organization. The founding team, me along with my 2 co-founders, all of us have been into robotics and AI since 2008. Been fortunate to read the research papers of some of the senior veterans who've joined us on this call today. Through our college years and the passion of building a consumer robotics business has gotten us to this point. We want to build it further and make it a global brand that would be present at 10 million homes and impacting lives across the globe. So thank you so much. And I eagerly look forward to interacting with everyone at the neural network page. Thank you.
Thank you, Sneh. That's absolutely fascinating. And the next one in our series of speakers is going to be Pierre Dillambourg, who joins us from Switzerland. Pierre is a professor at EPFL and will talk to us about their projects in education and perhaps add a critical note. Pierre, over to you.
Thank you, Tony. Can you see my slides?
We can.
So, yes, I will have a more critical voice. Not because I don't like robots. I've done 10 years or more than 10 years of things with robots in schools, but because journalists call me all the time and say, hey, at EPFL, are you going to replace teachers by robots? And I've been looking for many years about a smart answer to this question. And I did not find it except one answer that works quite well. Yes, let's replace teachers by robots. And then we also replace the kids by robots, and we can all go to the beach and have fun. So there is a misunderstanding about the benefits of robots. Let's take this robot. It's like the 2 previous ones that you have seen. One, it's about learning programming. This is called Miro. It has been sold 70,000 of them to schools and parents. If you do this kind of activity, probably you are learning a lot to manage to see this activity, not because it's Miro, because you do this activity. If you do this one, the next one, the same story. If you manage to program these things, not only you learn about programming, but you have to learn about physics as well. Now, if you do this, if this teacher is a stupid teacher, and instead of letting kids code themselves, he display the code on the blackboard or whiteboard and ask them to just introduce the code, they're going to learn nothing. So the first point I want to mention, the robot itself has no effect on learning. What makes learning is what's going on in the brain of the child. It's a cognitive activity. And when you have demanding cognitive activity, that produces knowledge. The technology itself does not guarantee that the child will engage into an intense cognitive activity. So I've been asked to the journalists, and what is the effect of virtual reality? Nothing. It depends what they have to do in the virtual world. What is the effect of tangible interface, of augmented reality? The answer is always the same. The technology per se has no intrinsic effect. What makes our children learn is the cognitive activity. And quite often, you need a parent or you need a teacher to make sure they engage into this rich cognitive activity. So I heard Tony saying, and many people saying, yeah, but the goal is individual adaptation of instruction to learners. Nothing against it. Individual adaptation makes sense. It's not new. That's always been the leitmotif of digital education, which has been my field for almost 40 years. It's sure that there is no one size fits all, that it's better to have exercises that are adapted to your level. But think about it. What future do you want for your kids? Mesdames et messieurs, do you want to have a school where every child will be sitting on a chair with his own laptop and doing some exercise? Is that the future we want to make for our children? Isn't it sad? And I like the bottom right picture taken by Miguel Nussbaum in Santiago de Chile, where the 3 girls are using the same laptop. And why? Well, quite often we had to put more than one kid per computer. And when you do that, individual adaptation is difficult because you don't need to adapt to one child, you have to adapt to 2 or 3 children. And what we've seen in the studies is that if you put more kids per machine, not 5, but 2, sometimes 3, then you actually increase the learning gains because social interaction is at least as important as individual adaptation. And sometimes when you have 3 kids, one dominates the 2 others and control everything. But here you see these 3 girls, if each of them has their own mouse, so they can only, each mouse can only act on some button on the screen, so that the 3 of them needs to be engaged in the collaborative activities. So I seen the title of this event, it's all about individual adaptation. Fine, I do not reject that, but it's only half of the story. We are social animals. We have a social brain. Our brain is based on language, and language is acquired through social interaction. So that's something we should not lose in mind. To have robots like this one for encouraging kids to tidy up their room, that are part of the social life of children. On the bottom right, you see that human intelligence has defeated the intelligence of the machine. So we've done things with robots in schools. This was the Cowriter robot, where we say to the child, we take children with handwriting difficulties. When you have handwriting difficulties and you are 7 years old, your school life is a beginning of a mess, because handwriting difficulties will propagate of any kinds of learning. 2 + 2, you still have to write 2 + 2. And so we say to the child, look at now, he needs to pass a test. Could you help him preparing the test? This is called the protégé effect in learning science. We teach when we are in charge of, when we are responsible of the learning of somebody else, we are even more engaged. Also learning by teaching, that's another expression to be used. And now is not a robot that is able to write, because from the robotics point of view, handwriting is very difficult, but he writes in the air, the letters appear on the iPad, and then the child takes the iPad and says, no, this is not correct. And then the child has to improve the handwriting of now, we will then imitate the child, and so on and so on. That was quite cool, but there is no way we can make this robot totally autonomous. For me, this is not serious. We had great results. This was a result by French therapists working with a child, and on this x-axis, you have the time. On the vertical axis, you have the quality of handwriting in terms of speed in blue and quality in red. And at the beginning, this child was writing so badly that we could not score his handwriting. There are standard tests to score the handwriting. And after these 30 weeks, he passed the level considered as normal development, both in terms of speed and quality. You would say, it defeats the purpose, because we had this nice robot, these nice learning activities, and it has an effect. No, mesdames et messieurs, this was not the effect of the robot. This was the effect of a very good therapist using a robot as one trick among other tricks. And it was the effect of learning activities. So what we develop in the background is an AI system that is able to analyze the dynamics of handwriting. So the child is writing on a tablet, and we use machine learning. We train with 10,000 kids, some of them having dysgraphia, some of them not. And so that we can extract features of the dynamics of handwriting. So the speed, the pressure, and the tilt of the pen 240 times per second. So the machine learning extracts features like the second derivative of pen pressure. A therapist cannot see pen pressure, but cannot even see, you can of course not see the second derivative of pen pressure. So we use the learning gain of this child was the quality of the relationship with the therapist. It was also the quality of the remediation activity. So for every analysis of the dynamics of handwriting, so the motricity of the fingers of the child, then we can propose specific games, when based on the profile, we can work on controlling pressure or speed or acceleration or tilt of the pen without handwriting, because these kids already hate handwriting. So you see, these are different ways to use robots. Let me come back one slide back. These are, finally, we could abandon the robot. I'm not criticizing research on human-robot interaction. It's still fine to explore. We cannot say today that, oh no, we cannot conclude today that there is no benefit. But I have more and more doubts about the benefits of having humanoid robots in schools. I have beliefs into the very activity that these robots can, or these non-robots, here we just talk about the tablets, can force a child to do. And the last video I have, this one, shows you something that is quite inspiring. This is not at all inspired by a human being. And I would criticize here the idea that we try to design humanoid robots that do more or less the role of a human teacher for several reasons. First of all, we don't have a lack of human beings on the planet. We probably need to improve teacher training, but we don't have a lack of human beings to be able to be trained as a teacher. Second, to say the truth, even if AI has made fantastic advances, even at the time of ChatGPT, the most intelligent humanoid in the world is more stupid than the most stupid teachers in the world. For some clear reason, the robot never knows the context of some activities in the classroom. So we have to be maybe changing our mindset and not focusing on making robots that imitate human beings, on making robots that imitate dogs or imitate other kinds of animals. That's a lack of imagination. So my message today, maybe we should escape from this imitation game where we say, okay, we have humanoid, we will then ask them to play the role of the teachers. We have teachers, we can do probably more creative things with robots than imitating humans. Thank you.
Thank you, Pierre, for that thought-provoking talk. And our final speaker joining us from the United States is Laura Bocanfuso, and she's the CEO at Van Robotics. Laura, we don't see you yet. And just waiting for Laura to connect. If you have any questions for our speakers, be sure to type them into the chat window you see next to the video. We'll pick them up in a Q&A session later. Okay. So Laura, we can't hear you either. No. I don't think so. I suggest we move to the Q&A session. Laura, if you could try and connect your audio, or then we'd still listen to you and see your presentation. But for now, I'm going to ask a number of questions actually to our panelists. And I think I'd like to start with Tony Prescott. So, Hi. So it's kind of interesting that robots are changing from being this this coding tool that enthuses children about STEM activities to taking up more of a role as an educator. But how do you see that happening? So it's really interesting that Pierre says, like, we shouldn't try to imitate or kind of build robot teachers by imitating the humanoid form. And you've moved to this kind of, rabbit puppy with the Miro Robot. What were the design decisions behind that? And how are these robots then different from the humanoid robots that we typically see as a replacement for teachers?
Yeah, I mean, we were interested in alternatives to sort of human-like teaching assistants, and that's partly because of the expectations. I mean, besides Pierre's very sensible remarks about we're not wanting to replace human teachers, we also are not at a point where we can replace human teachers, and the humanoids that we have currently lack the ability to, for example, understand children and the learning that they need to do. So they can help in some learning tasks, and I think the experiments you've done have shown this, where we design them specifically for that task. But that we're far from having a sort of general purpose robot teaching assistant. And the risk is if you present children with a robot that's in humanoid form, they will have an expectation that it will be able to do the sorts of things that humans can do. So we chose an animal-like form in order to have children have less expectation, particularly with an animal like a rabbit. You wouldn't expect it to understand what you say or to speak back to you. And even though computer speech recognition has come a long way in a noisy classroom, we still have problems getting robots to hear what children are saying. And child speech is more difficult than adult speech. So with an animal-like robot, you can be non-verbal and children don't think anything of it. We also didn't want to make it like any particular animal, because if it looks too much like a puppy, people will expect it to bark and chase sticks and so on. So we went for a sort of general animal-like form, which would encourage interaction. And the third thing was we wanted to encourage physical interaction because robots are different from avatars and computers in that you can actually touch them and you can have a positive physical interaction with the robot that you can't have with an avatar on a screen. And particularly from this idea of creating robots that might be like a classroom pet, the physical activity of touching or even stroking a robot can be rewarding and calming for children. And we've done experiments that demonstrate that. So I think the way I see it is that we want to have these robots which have a more AI enabled, so we can start to use them as teaching platforms for children to understand not just coding, but AI more generally, and to see how it operates. But we also, it would be good to have robots in the platform that do something that teachers don't do or don't do as well, which may be the more pet-like functions.
Okay, thank you. There's a question from the audience from George, probably joining us from the US, judging from the question. And he asks he says that in his experience, there's not really a difference in how children engage between girls and boys up until the age of 14. And then suddenly there's this divergence in interest, and girls generally don't tend to be interested in STEM subjects after that age, and boys tend to kind of follow the stereotype of being interested in everything technical. Is there a way in which robots can be used to remedy that, if that is even needed, if that even needs remedying? Perhaps, Pierre, you've got some ideas on how to address that gap between genders.
No, but I thank you for sharing the question. Now we see exactly the same in Switzerland. So we do a lot of things, robotic for schools, elementary school, and then beginning of secondary school. And then it's around that age. Yeah, you are right. George is about, 13, 14, when they make the choice for which high school they're going to go. And that then we lose a lot of girls. There is a lot of social dynamics, unfortunately, and we have not been. So one thing we have done is to have class only for girls. So robotics only for girls. That was controversial. Coding only for girls, so that at least they would feel comfortable among themselves and so on. But 10 years later, we still have the same ratio of 30% women entering our School of Engineering. So unfortunately, I don't have the magic there.
I think the it becomes evident when they reach age 14 because they ask to choose between different subjects. But the stereotyping really begins very early, even from age 4 or 5. Girls are showing sort of some preferences which suggest the influence of stereotypes. So I think the answer could be to have interventions really quite early on in primary school to try and redress the balance, and creating robots that are designed for girls or more inclusive of girls might be part of it. We did some experiments with a boy robot or a boy-like robot, and the girls responded differently to it than boys, and I think appearance can be important.
Okay, thank you. There's a question from Safi, actually addressed to Sneh. She would like to know if and how the robot evolves together with the child. So I assume if the child is growing up, how does a robot keep track of that evolution?
That's a great question. So basically what we try to do is we try to identify, build a mood profile, interest profile, identify the personality profile of the child over a period of time, and basis that our framework will try to change its own outlook. If a child is super introvert or a child is super active and very extrovert, then the kinds of experiences that the robot would recommend would be very different based on what the parent desires as the outcome. So your Miko at your home will be very different from my Miko at my home, and because their focus and objectives are totally separate. Over a period of time, we've started on working on adaptive personality, where the core persona, the character of the product keeps changing, and those will be observed by kids over a longer period of time and so on. So the first stage of development was first understand the child. How do we are able to profile and understand the child? After cracking that, we started focusing on how can the robot make recommendations to the child for starting new experiences. Then we got on board all sets of experiences. Now we moved on to that stage where the product itself and its persona changes with the child and so on. So it's been every year there are certain R&D goals, and this has been work in progress, which we've been doing right now.
Okay, thank you. So another question from the audience. Many of these robots will have some form of artificial intelligence driving what the robot's doing. And given that these robots are aimed at children, perhaps will be used at home as well. How do we go about issues around, privacy, ethical aspects of using AI and robots? Thinking of even the large language models that might be used there. How do we kind of make that AI safe in these application contexts?
So, is this question for me?
It could be. Yes, go ahead.
So I guess there are two things here. One is privacy. One is the ethical aspect of it. I think when it comes to privacy, there are very well-defined norms in different parts of the world, be it COPPA in the US, GDPR in Europe, and cybersecurity policies in Australia and other countries. And I think global governments have started bringing it up to speed, coming up to speed on setting these frameworks for users and especially kids. So consistent third-party audits running on the data management processes by organizations is something that we've imbibed from a very first generation of robot itself. Because we knew for us, brand trust is more important than profits. And so therefore, once a parent can trust us, it's only then that we will be able to add real value into the life of the child. So the ownership of the entire data lies in the hands of the parent. There is no, we ensure that no personally identifiable information reaches to the cloud and so on. So you build in these frameworks, ensure as much computing capacity is there in place to take care of vision data being on the robot and these kinds of layers that you built in, and you keep communicating about the efforts that you're taking as a company to the parents on a consistent basis, and keep taking feedback from them. Now coming on the ethics aspect of it, I think there are no commerce objectives, there are no marketing objectives, there are no vested interests of the brand in trying to do that. So once your principles of your mission statement are very crystal clear at the outset, then parents do realize that and appreciate that very, very highly, because you would never see a Miko robot coming and recommending to you about a certain brand and trying to do all of those things. So therefore, being at that point of ensuring that you are adding real value and documenting that value and presenting it to the parent, and staying away from any additional ways of like, we call this term internally within we meant to call out this term a lot, of being consciously capitalist, where you have a goal towards your shareholders and so on, but you're conscious enough to ensure that you've not crossed the line. And I think if you're focused onto that, then everything is fine. They'll reflect in your ESG goals and your SDG goals as a company.
So another question here, some concern that we often hear, a question by Jiwat Ram. And he would like to know if using robots doesn't really contribute to social isolation. What if children enjoy spending more time with the robot than with people? Is that a concern? Is that something that we worry about? Perhaps Tony and Pierre, you can contribute to that.
I think yes is the answer. I think we have to ensure that robots help scaffold relationships between people, and that is one of the potential uses of the robots. I mean, there's good evidence that they can act as a kind of icebreaker, for example, in group situations. So if you design the interactions that it's a group interaction, then the robot can have a positive benefit of maybe getting people to communicate more with each other. And there's some evidence of that from users of the Paro seal-like robot. I just wanted to go back to the previous question, actually, because I think one of the ethical concerns about robots is that they can sometimes be doing things covertly that the user might not be aware of. And I'm concerned about robots that, for example, have these sort of animated screen eyes, but have a camera. And so the eyes can appear shut, but the camera can still be functioning. And I think we have to be careful of that in particularly childcare settings, because it can look like the robot isn't looking at you when the camera is still operating. So we need to design these anthropomorphic features, making sure that there's no sort of covert surveillance going on. And more generally, we need to make these things transparent. And I agree with Sneh, we want to put the processing on board the robot where there's any data that has privacy concerns. But there's a bit of a tension there, because you want to export some of the more intensive AI functions to the cloud. So resolving that is still, I think, something that's in progress. You know, we have to think about how to do this safely while protecting privacy.
If I can jump in on the risk of addiction, I would say it is a theoretical risk. Currently, children can get bored quite quickly about robots. After, I don't know in your case, but after a few weeks, not even months, a few weeks, they want more. They want robots to make silly things. They want to have surprise. They want to have, we have not reached a point, and that's maybe a good news, that robots are not good enough to create addiction, because it's difficult to create a device that keep the engagement over long periods of time.
Okay, thanks. So another question here is, why do we build robots? So we could typically also use augmented reality or virtual reality to create characters that appear to be three-dimensional. And that might even be cheaper to roll out across the homes or schools. So why is it that this physical form is so important? Is there a benefit to having a real tangible robot? Who would like to start on that one?
Well,
sorry, go on.
There's been evidence that the physical presence of a piece of plastic, basically, a piece of plastic with an iPad inside, has still an effect on this, especially for cases like telepresence and so on and so on. So there is short-term evidence. I don't know if there is long-term one. Most of studies suffer from being basically measuring a novelty effect and not often a long-term effect, except maybe in the study that Sneh has presented, but quite often there is no long-term effect. But otherwise, my talk precisely expressed my skepticism that the cost-benefit ratio of having a humanoid, while if you took the handwriting problem down the roads, we could get rid of the very expensive humanoid and integrate the AI into a tablet for a low-cost product. And so it was still useful to do research on human-robot learning, but down the road we managed to say, well, the real thing we need was not the robot in this context.
I think that the issue is that kids have an incredible large amount of screen time already. So the robot gives them an alternative to screen time. It potentially could be more physically engaging. I mentioned already that you can physically touch the robot. So we've got another modality that's not available in your avatar. You can actually physically interact with this thing. And it behaves in the real world in the way that avatars never do. So it's in the same environment as you. It can act on objects that you're acting on. And so I think we've still got a long way to go in terms of taking advantage of that. And I think that's what we need to do in education robots, is to do the things we can't do with screens, where having a physical device really makes a difference.
And another question is relates to the availability or accessibility of this robot technology. So Sneh was mentioning that his robot is being sold at a price point of $200 US, which is relatively low, actually very low for a robot. But I can imagine that most robots that are out there are much more expensive. So how do we deal with that? Because robots might increase the digital divide, might increase the digital divide, so the distance between people who have robots and people who have not. What can we do about that? Perhaps, Tony, would you have any suggestions there?
I think I'm impressed that Sneh can build his robot and sell it for that price. The proposal that we made in our white paper is that what we can do is we can, rather than having robots in every school, we can have some resources which are locally available in the community, or even have buses traveling around with robots on them. And I think there's inevitably going to be a limit to what kind of robots you can sell as an education platform, but the robots you'll meet in a job might be very different to those. So we also want to give children experience, for example, of industrial robots. So there may be a way of bringing these robots into settings such as libraries, where children can come in and experience the robot and see actual robots that are used in industry and get some experience of those. And that's what I would like to see. I think there's ways of doing that, and there's potential ways of recycling robots that have been used in industry, but maybe are an old model, and bringing those into education. And there are a lot of robots I'm aware of that are sitting disused in universities and probably in companies, and we could bring those in as education platforms.
So I guess adding on to the scale aspect, I think one very important aspect that we've seen is we build a proper QFD on what are the key attributes really required to get your desired impact point, and just bring in those things. Something that we've seen that a lot of robots we try to generally globally, robots are built with multiple actuations and degrees of freedom to achieve a certain goal, and the more problem statements you try to give it to the robot to solve, then the cost keeps going higher and higher. So it has to make, for a consumer to buy it for their home, it has to fit into a price point. So we've evolved into a more subscription model as well, so where you could buy into the robot at a lower price point and go into a bouquet of services and content and subscribe to them, so that it makes economic sense for a consumer to go ahead and buy it, and at the same time get the desired output and value at it. So yes, I think we're all in favor of building cutting edge technology and making it mass affordable and going in that direction and bringing in a business model which could make sense for the consumer and for the company and for all our partners along with us.
Okay, thank you. I'll take another question from the audience, and here's a question from Danny. There's a question about shy children. Would children who are shy respond differently to robots? And could a robot mean something for a child that is shy? Who would like to come in on that?
I think there's also, the question there about robots for children with autistic spectrum disorder. So I think the general idea, I think, is that educational robots might be good for a whole diverse range of different children, particularly children, for example, shy is kind of social anxiety. And interacting with the robot is hopefully more predictable and therefore potentially less threatening than interacting with, maybe, for example, another child. And I think one of the promising ideas is to use robots to try and scaffold social skills so that you can try things out with the robot. You can interact socially with the robot. It should give you positive feedback, and then it can encourage you maybe then to interact with others. So I think there is sort of good news there that robots could be quite effective tools. And we've done work with taking robots into schools with children, some with quite profound disabilities, and we've found that there's a really good positive response from children. And I think the idea that the robot is there and it's not necessarily judging you or seeing you in the way that other people will, so that it can be easier for children to engage.
So to answer that way, same way to Aquinaldo, you will find a lot of papers on using robot for autistic children. But we have to understand one thing: we don't decide what the children will project on the robot. We have seen one of our robots was just a box with 4 wheels and 2 eyes, which were not just 2 circles that were pretending to be eyes. There was no camera, no microphone, nothing. And yet kids project a lot of anthropomorphic features of intention, goals, and so on. So we have to be aware that our intention when we design a robot will not be what the kids will actually project as features, properties, human properties on the robot, and that two kids might project totally different features. So that's not under control.
Okay, thanks. Perhaps another question. So right now, we don't really see these robots in the classroom just yet. We don't see them really being taken up in education. What are the barriers there? Is it really because we don't know enough about them? Is it the price or the cost of introducing that technology in the classroom? What do you think are the main barriers, and where should we focus on to actually get these robots into classrooms and into people's homes? If we need to do that at all, of course.
I will give my negative answer then. I mean, it's not true. I mean, the small ones, the programmable robots like the one from Tony, the one from Sneh, or even if they're not programmable, the small robots, we see more and more of them everywhere. It's almost became, at least in rich countries, it became something that is quite widespread. Why we don't see more humanoids in schools? It's because we have not found useful ways to use them. We have not found practice where they are reliable. Tony was explaining that voice recognition in the classroom, you forget about it because the background noise is such that there is no voice recognition. And so they're not reliable and they're not at a level that we can justify having them. So it's just, we're not there. The technology is not convincing to be used as someone who could help the teacher to manage a classroom. That's an idea that many people had. the teacher is sometimes overwhelmed, so he has an assistant. This assistant is a robot, but this robot has to be smart enough to be a good assistant.
Good. I can speak to the barriers in the UK. So the money's a big barrier. Schools don't have very much money, and buying robots for the classroom is an expensive cost. That's one barrier. Another one is the teachers don't have the time to do the training to understand how to use the robots. Quite a lot of these barriers stem from the curriculum, which doesn't include robotics. And often the computer science isn't core for most children. It's something that they do as an option. So the teachers are focused on the curriculum, and this is something extracurricular that they don't have the time or the training to do. So I think some of these things we can fix through teacher training, and we're working with the STEM Learning Centre to try and provide those tools and to help teachers understand how they can use robots in the classroom. Some of them, I think, will require sort of government level understanding of the challenges of educating children for the jobs of the future, and how important it is that they get experience while they're at school of the technologies which are going to be in their lives when they grow up. We don't know what the technologies will be, but it's a fair guess to say that there will be more AI and more robotics for children, and that there'll be more of that in the workplace. So I think, sort of enlightened governments would see the benefits in giving students experience of these things in school, and hopefully we will see more of that.
Okay, thanks. But perhaps as a final question, so what are the hot research topics in educational robotics? And let's talk about large language models. Is this going to have an impact on robots in the classroom?
I think LLMs will definitely play an important role in improving the entire conversational experience going forward as well, and the NLP experience that kids have had. But the point is, besides that, there's a lot of focus needed on emotional intelligence and collaborative co-creation along with a piece of technology, where kids and the robot can come together in the right frame of mind, where the kids come in and collaboratively work towards problem solving and engaging on the curiosity of the child, besides just plain conversational LLM kind of experience. So there's a lot more work to be done and the headroom for innovation is massive.
In my case, I would say there is a lot of space for two things. One is swarm robotics, so not individual robots, but swarms of robots. And the second one is soft robotics. Robots made of soft material, paper, tissue, whatever, and that can act as kind of mind opener, that the robot is not necessarily a check, that the robot can be a very different device with soft components that are actuated in some way.
Yeah, I think as Pierre has mentioned, there's an increasing focus on active learning in the classroom. So the idea that we might have a robot as an alternative to a teacher is, I think, not trending in research on educational robots. There's much more interest, I think, in robots as learning tools that are going to promote kids to explore challenges, sort of the maker kits, for example. So build yourself a robot out of these bits of electronics and see if you can get it to work. Or maybe the robot as a kind of co-learner. So you're explaining things to the robot. So the robot can be the not very smart device that it is, but the child can have the task of teaching the robot something, and therefore the child has to be able to understand and process that in order to communicate in some way with the robot. So I think these are all interesting things that I know research projects are looking at right now.
Well, we're still going to be busy as academics for a little while. That brings me to the end of the Q&A, and you might have noticed that we were missing one speaker. So Laura Bocanfuso unfortunately couldn't join us due to technical problems. it remains for me to just thank our three panelists for joining us. And if you would like to stay and chat, you can do so in the neural network. And so thank you very much for joining us.
Thank you.
Thank you very much.
So much.
Bye.
Thank you very much, Tony, and a big thanks to all our speakers today, as well as to all the participants for making it such an interesting discussion. And now we encourage you to check out the AI for Good program online to see more robotic sessions that may be of interest to you. And we are very much looking forward to engaging with you in our upcoming events. And this is the end of this section and the start of the networking in the AI for Good neural network with the panelists and participants for the next 15 minutes. So see you all in a couple of minutes now, and I will give the floor back to Anna for the closing information. Thanks a lot.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
AI is a powerful tool.
This summit can help ensure that artificial intelligence charts a course that benefits humanity and bolsters our shared values.
you.